So now we're going to start solving rational equations. So basically equations that has fractions in them. Okay, so we're going to spend 2 days on it, looking at two different cases. And today the only case that we're going to look at is when there is one fraction on each side. And you've actually already seen this before. It's a proportion. When you have one fraction on each side set equal to each other, what we can do is cross multiply and just solve for the variable. And then the last step, step 3, is you have to be careful when we have a fraction because we need to check for extraneous solutions. Whenever we have a fraction, we said that we can never divide by 0. So if there's an x in the denominator, you got to make sure that whatever your answer is that you solve for x does not make the denominator equal to 0. Otherwise, we have a problem. So any x value that makes the denominator equal to 0 will be an extraneous solution. Remember, an extra strange solution that actually doesn't work. So we just have to check our answers. Let's look at A. We have x over 4 equals 8 over 7, one fraction on each side. We're going to go ahead and cross multiply. And when you cross multiply, it doesn't matter which one you do first. So I'm just going to do 7 times x equals 4 times 8. Okay, and then from there we just solve like a normal equation. Divide by 7. And x is just going to be 32 over 7. You can leave your answer as a fraction and then reduce your fraction if you need to. Okay, second case, the exact same thing. We have one fraction on each side. We're going to cross multiply. And when you cross multiply the 2, you just have to be careful to distribute. So it's 2 times x plus 1. You're multiplying the 2 to the x and the 1 equals 4 times 5, which is 20. So distribute the 2. 2x plus 2 equals 20. And now we have a linear equation that we can solve. So minus 2 on both sides. 2x is equal to 18. And divide by 2. X is equal to 9. And that's our answer. And now because we have an x in the denominator, we have to check to make sure that the 9, when I plug it back into the fraction, does not make my denominator equal to 0. In this case, when I plug 9 in, it's going to give me 10 in the denominator, which is fine. Let's look at another one. Very similar, one fraction on each side. We're going to go ahead and cross multiply. Okay, again, it doesn't matter when you cross multiplying which one you do first. So I'm going to do 3 times 4x plus 5. Remembering to distribute, so I put the parentheses there to remind myself. And 9 times x plus 1. And then we distribute. So 12x plus 15 equals 9x plus 9. And we want to move all our variables to one side of the equation. So let's minus 9x on both sides. And then we have 3x plus 15 equals 9. Let's minus 15 and move that over. And we have 3x equals negative 6. And then finally divide by 3. Okay, and x equals negative 2. And so again, let's check. If I put negative 2 back into the first fraction, negative 2 plus 1 is negative 1, which is okay. I just don't want it to be 0. It's okay if it's negative. 4 times negative 2 in the second fraction is going to give me negative 8 plus 5 is going to give me negative 3. So still not 0. So this is an okay answer, not extraneous. And then last one there, we've got, again, one fraction on each side. We're going to cross multiply. Okay, so I have 1 times x minus 2, which is still just x minus 2, equals 1 times x minus 2, so that's just x times x minus 2. And then again, I'm going to distribute this x through. So x minus 2 equals x squared. X times x is x squared minus 2x. And now this one's a little trickier because I have a quadratic. So no matter how I try to rearrange, I'm never going to get x by itself like the problem on the left. When we have a quadratic, we want to move everything to one side and set it equal to 0 so that we can factor. And when we factor, we want to keep it so that our leading coefficient is positive if possible. That would make it easier to factor. So I'm going to move everything to the right side so that this 1x squared stays positive. Okay, so I'm going to minus x, and I'm going to add 2. Just move everything to the right. So I have 0 equals x squared minus 3x plus 2. And now I'm going to factor. So, using your x factor method, I need to find, I keep hitting that arrow, two numbers that would multiply to give me 2 and add to give me negative 3. So that would be negative 2 and negative 1. Okay, so that would be x minus 2, x minus 1. And then once I factor, we're going to set each factor equal to 0 and set up our little mini equations. And we're going to have two possible answers. So x minus 2 equals 0 or x minus 1 equals 0. If x minus 2 was 0, x would be 2, add 2 to both sides, or x would be 1. So these are my two possible answers. And then again, remember we have to check them both to make sure that when I plug 2 in to each fraction, or when I plug 1 in to each fraction, it does not make my denominator equal to 0. And in this case, we do have a little problem. We have an extraneous solution with 2, because when I try to plug 2 into this fraction right here, I'm going to have in the denominator 2 minus 2, which would give me a 0. That's a problem. Okay, but 1 is okay. So in this case, 2 is my extraneous solution. So it doesn't work, and our only solution is x equals 1. That's our only answer. So when you have rational equations where there is one fraction on each side, you're going to cross multiply. Remember to distribute if you need to, and then once you cross multiply, you solve the equation like a regular linear or quadratic equation.